Okay, in this chapter we will discuss configuring DNS zones. Just repeating the first 3 slides. So the agenda for today's lecture will be covering DNS zones, understand DNS, and configure and manage DNS zones. DNS stands for Domain Name System. It is used by TCP/IP for naming. It's a naming service used by TCP/IP. And it is very important for TCP/IP, by the way, and for your internet. It translates URLs to IP address. In the early days, or many years ago, we were using host files that have the record for the DNS. Yani in the early days, we used to do name resolution using host files. Name, IP address. Okay, URL, this is the IP address, URL, but this is not practical, right? Because now we have billions and billions of websites. So the benefits of DNS, as I just mentioned, first of all, it's easy of use and simple. It is scalable. When your network grows, also your DNS can cope with it. It can handle larger networks. And it is consistent. When you type a URL on one computer in your network, you will get the same IP address if you type the same URL on another computer. The fully qualified domain name maps a host name to an IP address using the DNS. For example, here we have computer1.sales.microsoft.com. This is an example of a fully qualified domain name. In this name, what is the host name? Who can tell me from here, from this? The host name is to the left, computer1. And it is computer1 is located in the sales domain, which is located in Microsoft, which is, we call it the second level domain, which is located in the top level domain. So the last one here, we call it top level domain. This is the second top level domain. This is a domain, and this is a host name, okay? DNS is hierarchy. It's using hierarchy method. So as you can see here, we have computer1.sales.contoso.com. We can have mit.edu, okay? Now, we just mentioned some of the terminologies or terms used for DNS. Each node or leaf in the domain name is called a resource record. Each node or leaf in the domain name is called a resource record, or RR. The RR holds information associated with the domain name. Top level domain, we already seen that, .com is an example, consists of a generic top level domains and international country codes. Then we have the second level domains. They are registers to individual or organizations such as .microsoft, .cisco, right? Cisco. A host is a specific computer or other network device in a domain. Could be a printer. The address resolution mechanism used by DNS. We have the first method is recursive, using a recursive query to perform DNS forwarding when needed. So here I have a client. The client has a DNS client installed on it. It is requesting sending the query to the primary DNS server. The primary DNS server, if it does not have the answer, if it does not know about this record, it will send it to the second DNS server. So it's called recursive. Okay. Iterative, what will happen here? DNS client will send the request to the primary DNS server. Let's say it is contoso.com or computer1.contoso.com. Computer1.contoso.com. You will send it to the primary DNS server. The primary DNS server first will send it to the top level, which is .com, to the root. The root will send, okay, you are looking for .com. I will send it to the .com, to the com server. The com will receive the request, and then it says, it sees that it is looking for contoso.com. So then it will send it to the Contoso server, DNS. When it arrives at the Contoso knows that, oh, okay, I have computer one in Contoso. Then it will reply. Okay. So this is called iterative. It is done on parts. First one is recursive. The second one is iterative. A resolver is a client program that generates DNS queries, and then it sends them to a DNS server. The resolver has direct access to at least one DNS server and can also process referrals to direct its queries to other servers when necessary, of course. We already mentioned that we have two types of referrals or queries. Okay. So we have two types of name resolution in DNS server. We have the recursive query. The DNS server receives the name resolution request. It takes full responsibility for resolving the name. If the server does not, or if the server possesses information about the requested name, it replies immediately to the requester. That's why it's called recursive. It's taking full responsibility. Receive the request, it will reply. Iterative, the server receives the name resolution request and immediately responds with the best information it possesses at the time. This information could be cached or authoritative, and it could be a resource record containing a fully resolved name or a reference to another DNS server, like we saw in the example here. DNS servers use iterative queries when communicating with each other. This is the iterative as we saw here. You see, it is going, the request is going to the primary, and then each of these DNS servers, they are communicating with each other using iterative queries. Go back here. To deploy DNS, as we will see in the lab, we will install DNS on one or more server. Actually, we will install it on one of the servers. We will configure it. We will create a forward and reverse lookup zone. We will add resource records, and we will configure the clients to use the DNS servers. This is how we install it. We will do this in the lab. So I'm going to skip these slides. Hosts and LM hosts. The hosts and LM host files are used for name resolution, and they are stored under this folder. Okay, directory. LM hosts, they are used for the net bias. Okay, you need to know this. LM hosts, they are used for net bias. These are some examples of host names. A host name represents a logical element that is assigned to a device. Okay. It is unique and it is used to identify the host in a network, which is called a domain name too. So here we have computer name. This is the computer name, and we have the full computer name. And this is the domain name. You see the domain name? duwati.local. It is here also in the full computer name. The computer name is this part only at the beginning. All right. We have different types of DNS zones, but they are all hierarchical because DNS using a hierarchical structure. The primary zone stores the primary copy of the DNS database and maintains all DNS zone records. Then we have the secondary zone, acts as a backup of the primary zone. Whenever the primary zone is unavailable, the secondary zone will kick in and resolve the DNS queries. We have also the stop zone, represents the secondary zone with no editable primary copy of the database. It's a secondary but not editable, and contains sufficient information to identify the authoritative DNS. Okay. The authoritative DNSs can either be configured manually by the network administrator or system administrator, or dynamically by other DNS. Okay. The non-authoritative DNS contains the cached information that has been constituted by previous DNS lookups. Now, once we install DNS, you will have option. The system will ask you, do you want to install? Do you want to use Active Directory to store your DNS? Actually, there are benefits to do that. Why? Because if you do that, if you store DNS with your Active Directory, then you get fault tolerance. You take benefit of the fault tolerance of Active Directory. You are more secure with the Active Directory, and you get better, efficient replication. What is replication? Replication is when one DNS is replicating its contents to the others. Replicating, that's the meaning of replicating, sending the copies of changes to another server. We have different scopes of replication. We can duplicate to all domain controllers in the domain, or to all domain controllers that are DNS servers in the local domain, by default, by the way, this one. Or to all domain controllers that are also DNS servers in the entire forest. We will learn more about forest. The middle one. You get these options here. When we do the lab, inshallah, we will study them. This is how to create your standard forward lookup primary zone. You can also configure forwarding, conditional forwarding. When a client contacts a DNS server and the DNS server does not know the answer, as mentioned before, it will do iterative query to find the answer. So the DNS server can be configured to be forwarded to another DNS server or a conditional forwarder based on the domain name queried. What does this mean? Yani, if I receive a request, if the request contains .com or .microsoft.com, I will put a condition, I will configure conditional forwarder. When I receive this, send it to this DNS server. So it's condition forwarder. A forwarder controls name resolution queries and traffic. It can improve the efficiency of name resolution on a network because you can control the traffic. When does the zone transfer happen? Or what triggers the zone transfer? The whole information of the zone. The events that trigger the zone transfer are: the initial transfer occurs when a secondary zone is created, or if the zone refresh interval expires, or if the DNS server service is started at the secondary server. When you start it at the secondary server, it needs to do the zone transfer. Or the master server notifies the secondary server that changes have been made to a zone, so please do the zone transfer. So these are the 4 events that could trigger a zone transfer. Because it's not happening all the time, because this causes traffic. Okay? There is a duration for the refreshing of the zone, because the zone have some information, right? This information is not there forever because it gets updates. So when the refresh time expires, interval expires, then it will need to get a new update. Like, remember when we talked about,
it's like creating a new zone.
Yeah, it's like the lease time. Remember when we talked about the SCP? It expires after the duration, let's say 8 days. Same thing here. The zone refresh interval you can configure. If it expires, then it will need to, a zone transfer should happen again. Okay. We have 3 types of zone transfers. We have full or incremental, only the changes will be transferred, or with DNS notify. We call it DNS notify zone transfer. By default, zone transfers are disabled, and you can choose one of the following to enable. To any server, allows a data transfer to any server that asks for a zone transfer. Of course, we don't recommend this because this is not secure. Any server requesting the zone transfer, will you send this to any server? Of course not. This is all your DNS information, sensitive information. Only to servers listed on the name server tab. So this one will restrict zone transfers to secondary DNS servers as defined with NS resource record. Okay, so only this one to the secondary, or you can limit only and put the servers only to the following servers. It will restrict zone transfer to those servers specified in the accompanied list. So this one is secure. You will only specify the servers that can request zone transfer. This is the configuration. We will see this in the lab once we do the lab, inshallah. Yeah, skip this. DNS records. A DNS record is stored in a DNS zone database. The database itself is made up of a collection of resource records, and they are used to answer the DNS queries. Each RR specifies information about a particular object or record. Each record has a type, an expiration time limit, and some type-specific data. We will see this when we create the records. Some records are, or many of them are actually automatically created. For example, clients or the DHCP servers create the host and pointer records. When you install a DNS server, NS records are usually created. When you install domain controllers, SRV records are created. So these are created automatically. You should know this. These are the records, some examples of the records that are created automatically. Any questions?